Hi, this is Inga Möck from Germany, and today I will talk about the energy transition in Germany from fossil fuels to geothermal energy. What's going on here in Germany? My co-authors are Rolf Bracke from the Fraunhofer Institution for Energy Infrastructures and Geothermal Systems, and Josef Weber from the Göttingen University, where I'm also professor. Well, the whole work goes back to our activities in the IEA, the International Energy Association, and the geothermal branch in Task 10 is data collection. And this working group collects geothermal energy use data, trends, developments from the IEA geothermal member countries and publishes all these reports. When you want to know more about these reports, then please go to this internet address that you can see here at the bottom of this slide. We have to learn some lessons today. This is for your convenience. You can learn German today. Energy transition in German means Energiewende, and heat transition in German means Wärmewende. Energiewende, Wärmewende. Yeah, energy transition, Energiewende, heat transition, Wärmewende. Keep that in mind. What about the energy consumption in Germany, the primary energy consumption? Well, when you look to this diagram, then you can see that district heating and space heating makes more than a quarter, almost 1/3 of the whole energy consumption. When we look then, or when we add to hot water and process heat, then we recognize the heat share of the final energy consumption is more than a half, more than 50%, 54% goes to heat demand, heat share. And the rest is then cooling, mechanical energy, information communication technology, electricity from lightning. In total, we need 9,151 petajoule. This equals 2,542 terawatt hours per year. When we look now to the energy sources that feed this heat demand, to fulfill the heat provision, what are the energy sources? Then the energy sources are coal, mineral oil, a big portion is natural gas, then the heat comes also from electricity, from district heating, and from renewable energy. The coal makes 500 petajoule from the 5,272 petajoule that we need to provide the heat. When we look now to the district heating and we look to the energy sources that makes district heating possible, then we see that more than 40% comes from natural gas, 12.6% comes from waste, burning waste and using the waste heat. Then almost 20% comes from renewable energy, and that is biomass. Then 6% comes from lignite. Almost 19% comes from coal. And a small portion from 1.4% comes from oil. The share of coal in district heating makes 130 petajoule. In total, we need at least 630 petajoule from coal. What's now with the Renewable Energy Act in Germany? The Energiewende-Gesetz is a Renewable Energy Act. What is a plan? The plan for renewable electricity was by 2000 or is by 2030 to produce 35% of our gross power production from renewable electricity. And what is the plan? The reality is that we achieved already in 2017 36% of our gross power production that comes from renewable electricity. So, yeah, we achieved our goal in electricity. What's with heat? Our plan is, or was, in 2020, we wanted to achieve 14% of our gross heat production from renewable heat. And what did we do? The reality? The reality is that in 2017, we produced less than 13% from renewable energies for heat. Since 2010, we have an increase, but then between 16 and 17, we have a decrease, and we are beyond our goals. We didn't achieve our goal. Germany has a heat problem. Not an electricity problem, a heat problem. Lesson 2. The major share of our primary energy is heat in Germany. And the renewable heat is the key for a successful energy transition. With other words, no Energiewende without Wärmewende. No Energiewende without Wärmewende. What about geothermal energy in Germany? We have also the country update presentation for Germany, but here I just summarize what's with deep geothermal energy. We have 38 facilities in operation, deep geothermal plants in operation in Germany, with an installed capacity of 350 megawatt and a heat capacity and electricity or power capacity, electric capacity of 40 megawatt. The facilities that are under construction is 4, and the facilities that are under development is about 30. So there's a lot activity and development. When we add the shallow geothermal to the deep geothermal installation, the shallow geothermal makes 6,300 megawatt thermal, then it sums up to a total capacity, geothermal capacity and stored capacity of 8,100 gigawatt hour in 2020. That equals 29 petajoule heat from geothermal facilities in 2020. Lesson 3. In 2021 in Germany, we are 2 years before the phase out from nuclear power and 17 years before phase out from coal. Our installed geothermal energy or capacity is 29 petajoule, and we still have to do 470 petajoule to substitute coal and around 1,000 petajoule to substitute fossil fuels. And we have only 17 years. In 20 years, Renewable Energy Act, we produced 29 petajoule, and we have still a lot to do. So how can we accelerate the whole geothermal development in Germany? Well, the first thing is to harmonize geothermal technology with population density and energy demand. So we have here the temperatures. This is a geological potential with high temperatures, high flow rate. So far, so clear. But we also have to look to our high demand structures. Here with the red colors, you can see the population density. The darker, the higher the population density. Well known is the area around Munich, where we have a high heat demand on top of a good reservoir with high flow rate and a good temperature. But what is with the other areas? And I will talk about these areas here now. The first potential area is the Rhine-Ruhr region here on the west of Germany. We have one of the largest heat and power grids and in Europe. And how to feed this heating grid, this district heating grid. One option is to utilize a limestone, Devonian limestone, comparable to the technology and methodology in the Munich area. This is one option. The other option is to use mine water for district heating plus a heat pump, and using pit water from coal collieries for excess heat storage and then production. And just an approximation is when we would do the latter option here, is that we could store and use heat energy of 17 to 29 gigawatt hour per year. Another potential is North Germany. This is actually the birthplace of Germany's geothermal industry, where we have the first heat plant installed in 1984. And now we look to this region from a renewed side. The one thing is to use medium deep geothermal energy. That means 45 to 60 degrees C plus a high capacity heat pump. An example site is the town of Schwerin, where they use 54 degrees C and 1,200 meter depth for district heating, and they uplift that heat by a high capacity heat pump. Another option is integrated energy concept with sector coupling and using geothermal subsurface with heating, cooling and storage. This is a living lab in Hamburg, Wilhelmsburg, with a joint project Mesotherm. Another potential is what I call the average. Medium-scale towns, medium-scale geothermal geology. An example is here in the Emsland, where we have small towns on top of sandstones, in this case Cretaceous sandstones. The colors here represent the deposits of these Cretaceous sandstones. And when we would drill into these sandstones, we could at least feed with an average temperature and average flow rate. We could provide half of the heat demand that they have there with 3 well doublets, geothermal, hydrothermal well doublets. What we learned from that is when we want to achieve our goals in Wärmewende, we have to use the whole variety of geothermal technology that is existing, from shallow geothermal for heating and cooling in rural areas, to eco-districts with sector coupling and district heating, storage and heat generation, heating and cooling, greenhouses, agriculture, wellness, tourism, spas. We need to use all these technologies when we want to make a success out of our Wärmewende. So this is what I have to say about heat transition in Germany. Thank you for your attention.